Hi friends, welcome to my channel. Let's have a look at problem 1490, clone N-ary tree. This is a follow-up video for the video for problem 133, clone graph. Actually, the treatments are entirely parallel to the treatments for problem 133. First, let's quickly look at the problem statement, and then we are going to look at the coding and explain them line by line. So essentially, you can copy the codes from problem 133, and then just make some modifications. First, let's look at the problem statement. Here we are given a root of N-ary tree, right? So if n equals 2, so we have the typical binary tree, right? So we would like to return a deep copy of the tree. So you can understand it as a clone. So each node in the N-ary tree contains a value and a list of its children. In other words, this class have two fields. One is the value and the other is the children, right? So this value is an integer and the children is a list. So N-ary tree input serialization is represented in their level order traversal, right? Each group of children is separated by the null value. So here are some examples, right? So here the constraints are the following. First, the depth of the N-ary tree is less than or equal to 1000, and the total number of nodes is between this 0 and 10 to the power 4. So these two numbers are the two ends of the given closed interval, right? So here there's a follow-up. Can your solution work for the graph problem, right? So actually we come from the graph problem, right? So if we just do some simple adaptations, that will do the job. So now let's focus on this problem. So here first we know that in the copy module of Python, so we have a copy method and deep copy method. So basically, for this problem, if you return by calling deep copy, right? So then make a deep copy of this guy, and then you do the test, and it will pass. However, I guess this is not the original meaning or the intention of this problem. So here we are going to ignore this one. So we are going to make this one as let's copy this one first, and let's change a name for it. Let's call it solution V, right? V naught, right? So it's just just to mention that we know we have this method which can do the job, right? But here what we want to do is to present some solutions either in iterative format or in recursive format. First, I'm going to present a iterative format solution, right? So this is based on traversal, right? You can do both depth first search or do breadth first search, depends on how we use the container as specified in the video for problem 133. So again, I want to mention that the concept here is called clone. So this is the terminology in biology, right? So biology. But mathematically, so it's called isomorphism, right? So this is in math, right? And mathematics. So with that said, let's look at the coding part. So this coding, basically, we want to build an image. So we are going to use a dictionary to make a one-to-one correspondence. So with that done, in mind, let's do the job first. Again, it's always good to check the edge cases. Though some cases we can absorb the edge cases in the general treatment, but let's first do this. If not root, basically we are going to return or return none if you like. This is one case. So next, I want to do traversal. Here, just because we have video for problem 133. So here I'm going to directly use depth first based solution. So I'm going to use a stack. So here S means stack. So we are going to add root to the stack, and then we are going to do the initialization for visitor set. This basically used to establish one-one correspondence for the original nodes and the image nodes in the clone. So then what we are going to do, first I'm going to map the root, right, to a node. So the node has the same value as the root. So we're going to specify this field, right? Value equals root value. I'm going to use default for children. So originally it's an empty list, right? So with that done, we are ready to do the while loop. So this is very standard. So you can do whatever traversal you want, right? So here we can use in order, pre-order, post-order, as you like. So here, because we have the root, so it's better to use pre-order, right? But you know, it does not matter what you do. So now let's first get a node. So basically spop. So here I will pop from the tail of the list. Basically, we want to emphasize that we're using depth first based solution. So we are going to use this as a container. So we are going to use as a stack. So we are going to use the tail as the top of the stack, right? So now what we are going to do? So then we're going to check children, right? For child in node children. So basically, I don't know how this tree store the children, if it has null or not. So now let's do a check. So if child, basically this makes sure that we are below, we will work on child which is not null. If child is not null, if child and child not invisited. So in other words, we haven't make a image for this child. Then we will do this here, visited child. Then we're going to map to a node. This is the instantiation of class object, right? The node object. And then the value will be the child value. In other words, you can understand this is a the isomorphism result of this original child, right? But from the coding point of view, you just need to know that we made a one-one correspondence. And then we're going to append this S, right? So if we do not have this line, it's nothing but just the standard traversal, right? Then afterwards, so we've treat the image if not. So what we are going to do is that we need to map the node children relation to the isomorphism or in the very corresponding side. So what we are going to do is visited child, right? Visited node. We want to consider its children. So its children will append the visited child, right? So here let's look at the relation. So we know that the child is a child of the node we're currently looking at. Then we want to make sure visited node is or let's see others. Visited child is a child of visited node, right? This is in the mapped set. So with that done, basically we are ready to do the return. So we are going to return visited root, right? This shortcode actually forms a solution format to this problem. Let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. So now with this solution done, I'm going to copy this part and write a recursion solution. So I'm going to call this one V1. Let's see, and let's change this one to be recursion, right? Recursion format. So here, let me make a comment. So if we pop 0 here and remain append to the end, this corresponds to breadth first based traversal, right? So you can adapt that to the terminologies in binary tree or N-ary tree traversal. So now let's look at this solution format. So in order to do recursion, so I'm going to initialize a dictionary. So this is basically help us to monitor the one-one corresponding relation or clone relation or isomorphism, isomorphism, if you like. Now what we are going to do, so I'm going to write a utility function. So this function basically do depth first search. So if you like, or just to interpret it like this, or just to see it's just a traversal, just a recursion. So here I'm going to accept a root of the tree. Let's call it original, right? And then what's the base case for this recursion? So basically, if the this node is already in D, so we just need to return D original. This is the base case, right? So now let's look at how to make the recursion call, right? So for this, now we're going to check if this node not in D. So what we are going to do, we are going to establish an image for it. That is the original equals the image. So we're going to call this image node. The value will be the value of the original node, right? And then what we're going to do, we're going to establish the parents and the children relation, right? So it's the image. So consider its children. So its children are going to be, so we're going to map this function to the children of the original node, the original children, right? So this will give us an iterable, but what we want is a list, so we can make a list tab conversion here. And then that's about it for this recursion function, right? So now step 2. So we want to do the return. So the return is simple. We want to return D on the root, if root. Otherwise, so we're going to return null. So this shortcode actually forms another solution format. So before we make comments, let's do a check. Here, what's the problem? If return D, I didn't call this function yet. So we're going to call f root. So let's see, not this one. So here D root f root. Now let's do the check. Yeah, it passes the case. Now let's look at the generic case. Yeah, it passes all the generic cases. So in this solution, as we mentioned in the previous video, so we can use packing or unpacking. So let's do this. Let's comment this part out. So what we mean is that we can do unpack for this one, and then put it in a list. This plays the same role as the above line, but a little bit faster. This might be less known to some people, but let's check. Yeah, it passes all the cases. So with that said, basically that's about it for this problem. So let me give a quick summary. So this video is a follow-up video for that of problem 133, clone graph. So basically the treatments here are parallel. In this video, we give two solution formats. One is in iterative format. Basically, you can do breadth first search and depth first search based solutions. And another solution is recursion format or recursive format. So here we wrote a utility function and then do the proper return. And in the return, we did a edge case check. So with that said, I guess that's about it for this video. If you find the explanation here is of use, you are welcome to share with your friends. Thank you.